Welcome to Azure Community Live, an online meetup by the community for the community. This is session number 4. My name is Esteban Garcia. I'm a Microsoft MVP and Microsoft Regional Director based out of Orlando, Florida. Joining me today is our Australia-based host, Lars Clint. Hi, Lars.
Hello, Esteban. Yes, I am. I'm sitting here. It's now in the future compared to you, and I will be hosting our meetups from the Australia region, and that will be hopefully very soon. We'll have some meetups that are hosted in this time zone as well. So we're working hard on that, and that will come very soon. So watch this space.
Awesome. So today, Monday, Tuesday for you, we have Santosh Hari and Florida-based Azure MVP. So, hey, Santosh.
Hey, how's it going?
Tell us about yourself.
Sure. So I am an Azure MVP. My day job is also an Azure consultant, so a lot of Azure. I work for a company called New Signature, which is a fantastic company. Some of you might be familiar with it. And I run the Orlando.NET user group and also run the Orlando Codecamp, which is in March. And I'm a speaker. I've spoken at various conferences. And CosmosDB is a topic of interest of mine. So certainly hoping to have a good chat about that today. And hopefully we can get some questions and answers going and have a great time.
Fantastic. So with that, today, Santosh, you're going to be talking to us about Developer's Guide to Azure CosmosDB. We look forward to it. So I'm going to transition to you sharing your screen, then we can get started. As a reminder to everyone, you're able to ask questions, and we're going to be taking a look at the chat. Santosh, we'll just stop you along the way with any questions, or whenever you want to take a pause, just let us know. Also, just to remind everyone, on February 11th, that we'll have our next session where we're going to be hosting Mark Fusel, where he's going to be talking about Dapper, microservices with Dapper. So keep an eye on this channel and come back and rewatch all these videos and be on the lookout for our next session as well. So with that, Santosh, take it away.
Thank you. So welcome to my talk, which is the developers guide to Azure CosmosDB. Today I'll be talking about a bunch of topics, mainly trying to channel the conversation DB. Great session, and feel free to chime in with questions. So I wanted to start off with NoSQL. So I'm not a big fan of the term NoSQL, but I use it for convenience. So what is NoSQL? It's, in my definition, NoSQL it's a data store that's anything that's not a traditional relational database. So what we'll do today is we'll talk about the main differences between relational and NoSQL data models. So NoSQL data model basically provides a mechanism for storage and retrieval of data that is not modeled in the traditional RDBMS format. NoSQL allows for simplicity of design, easy horizontal scaling, and finer control over availability. In relational databases, if you remember, we used to, horizontal scaling was really tough. So most machines used to scale vertically, which means you used to bump up storage, RAM, CPU on the machine, or move it to a bigger machine. In NoSQL, what we're doing is we're simply adding nodes and using commodity machines, and that scales up the database in terms of compute and storage. Uh, so the other advantage we get with NoSQL data stores is that it's schema agnostic, which means that it does not have to conform to any particular schema. So this helps a lot because these days, as we build applications and we are doing Agile, we're doing fast development, we want to spin up POCs or MVPs, and all of these, you often don't start off with like deep database designs. You write code, you get to a stable point, and from there you learn, you revise, and you move on. So a lot of times you cannot predict what your column and table structure is going to look like. So in that case, a schema agnostic stores that NoSQL databases offer is a great choice. You can also use these data stores for when the workload calls for cheaper storage, massive scale, low latency, or global distribution. It is often a misconception that NoSQL is because it does not support SQL-like queries. Today, I'll show you how some of our NoSQL stores do indeed support SQL-like queries. And we will also see the other misconception about NoSQL is that it does not offer relationships, which is also false because today we'll see some NoSQL stores that offer that offers the ability to provide relationship between entities. So if you want to think about it in a particular way, it's that NoSQL is really very similar to SQL, except that it does not. Most of the NoSQL store only offer a certain subset of the SQL features, and this is because you want to scale them across different machines, so you have to sacrifice one of the features. So just think about it that way. So some types of NoSQL data stores for structured and semi-structured data. By the way, NoSQL, you can get structured data, you can get semi-structured data, and you can get unstructured data. Unstructured data would be like files, images, and other things like that. Semi-structured data is like JSON data, and structured would be like a CSV table type data. So today we'll discuss mostly stores that deal with structured and semi-structured data. So an example of that would be you have document type NoSQL databases. MongoDB is a great example for ones that are used widely. You have graph databases. Neo4j is a popular one. You have key value stores. These are the simplest NoSQL database, so everyone is familiar with key values, as in you have C#, key value pairs and dictionaries and stuff. So these are stores that store that type of data. And you have wide column data or columnar databases, and these are optimized for query over large data sets and store columns of data together instead of rows. And we'll talk about all of these. In Azure provides managed NoSQL offerings, and some of them are Azure Storage. Azure Storage is largely used to store unstructured data like files, blobs, and so on. And it also has a Azure Table Storage, which we will see as part of Cosmos later on. Azure Data Lake Gen 2 is another type of NoSQL store, which stores unstructured data. It's built on top of Azure Storage. So those are kind of pretty similar. And finally, we'll talk about our main topic of discussion today is Cosmos. And Cosmos was formerly known as DocumentDB. It came out in 2015 and in 2017 using the engine that DocumentDB ran on. DocumentDB used to only support the document NoSQL storage. Um, Microsoft decided that that's a great engine and will add other types of NoSQL stores to it. So now it supports table, graph, Cassandra, Mongo, and documents. So that's that is the evolution of Cosmos. So what is Cosmos? It's Microsoft's uh, database as a service. It's only available on Azure. So if you were to go to AWS and ask for Cosmos, that would not be possible. It's Azure's. It's only provided by Azure, and it's fully hosted, managed, secured, everything done by Microsoft Azure. It's a multi-model NoSQL database. It supports SQL API, Mongo API, Cassandra, Table API, and Gremlin API. And we will discuss these in detail today. You can elastically scale the throughput and storage. As you can see from the map, you can scale it across various regions, and you can do this with a simple click of a button. You get fast single-digit millisecond data access latencies, which makes it really useful for distributing data throughout the world and and retrieving that data at blazing speeds. One thing to know about Cosmos is that because it's a database as a service, it is mainly available either through the API that Microsoft provides, or Microsoft SDKs provide, and or you can connect to some of the Cosmos models over the native wire protocol. For instance, you can connect to Mongo over the Mongo wire protocol. Low latency, so Cosmos DB guarantees less than 10 millisecond latencies for both reads and writes at the 99th percentile. This enables fast ingestion of data and super fast queries for highly responsive applications. Now, one thing to keep in mind, and I'll drop some of these developer tips as we go on, because it's easy to get caught up in some of the hype, but I also wanted to make sure that we understood what it exactly entails. So when we say it provides millisecond latencies, let's say you have an application hosted in the East US region of Azure, and the Cosmos instance is also hosted on the East region of Azure. This actually helps keep up with the SLA in that you can actually try to get those the single-digit millisecond latencies. Now, if you were to host in your application in the East US region, and then your Cosmos was hosted near Lars, which is in Australia, then it would be more than single-digit millisecond latency. So you have to be careful about where you host the application that consumes your Cosmos. This is helped by the fact that Cosmos is distributed throughout the world. Throughput. So this is something that I want to touch on before we jump into further details. Throughput is provisioned to ensure there are sufficient system resources available to meet or exceed the Cosmos SLA, which is for the reads and writes. Throughput is the cost of all database operations, and this is normalized by the Cosmos documentation team, and it's expressed in terms of request units. And one RU, or request unit, is basically the unit of reading a 1 kilobyte document in 1 second. So you'll see that we provision our Cosmos containers starting at 400 RUs. So that's a 400 That's the equivalent of reading a 400 KB document in 1 second. And this throughput, obviously throughput means both reads and writes. So if you're writing to Cosmos, you're reading from Cosmos, keep in mind that writes generally cost more because you have, after you write, the data has to be indexed. Multi-model. So Cosmos DB supports multiple models of data. If you want to store NoSQL document type data, you can use the SQL API or Mongo API. Basically, the documents are JSON documents. You can store a complex nested JSON data structures in the documents, and each individual field is a key value pair or a key array pair. Graph databases, they're used to store information about networks of data, such as social networks and so on. Key value pairs, again, you can store pairs C#, so it's just a, and wide column databases. These and Cassandra is a type of wide column database. You store the columns of data together instead of rows, and we'll talk about these in detail. So SQL API. The SQL API actually provides SQL query capabilities, and you have JSON style data, as you can see on the right-hand side of the screen. These are schema-agnostic data. So for instance, what you see on here is an employee record. The next record I store in here could be record about a department. And I can store that in the same storage space or container, as we call it. And it would not, as long as it's valid JSON, it will not, Cosmos will not complain about it. You can store massive amounts of JSON data, and you can write SQL-like queries, which we will discuss today, to retrieve this data. One thing I wanted to touch on is I have a bullet point in there that says new. This basically indicates that if you want to start building applications, you can start building. This is generally used in scenarios where you bring in new applications into Cosmos. So you can start building new applications in Cosmos with SQL API. And the reason I talked about new applications is because of the Mongo API. Mongo API is generally used for migrating applications that use MongoDB via protocol to over to Cosmos DB. And again, the data is very similar, and that it's JSON or BSON, which is the Mongo data type, very similar to JSON. You can point your existing applications that use the MongoDB via protocol. You can simply change the connection string, point them to Cosmos, and it would start working. And there have been instances of people moving over to Cosmos to use the Mongo API on Cosmos as opposed to a MongoDB instance because of security reasons. And you've seen a lot of that in the news probably recently. Table API. The table API is kind of a key value pair. It's the same tables that you find in Azure Table Storage. The Cosmos DB supports higher throughput, throughput optimized. So we kind of call them premium. It's like premium tables as opposed to Azure Storage tables, which are more general usage. You can also you can continue to use Azure Table Storage for tables with high storage and lower throughput requirements. But if you want to use premium structure more of a premium performance level, then you move over to Cosmos. So the additional advantage, and this is where I lost my chain of thought, is the additional advantage of using Cosmos for Azure Table Storage is that you get to use secondary indices on this table, which you would not get to use with Azure Table Storage. Gremlin API, this actually provides graph type database. So a couple of disambiguating terms. Apache Tinkerpop is the computing framework, and Gremlin is the traversal language. So these are data. Data in the real world is more naturally connected than we'd like to do in relational databases, and these type of databases offer a more free-flowing structure for adding relationship between entities. So, as you can see from this image, you have multiple entities known as vertices, and they have relationship that are known as edges. So you can add as many edges as needed between the various vertices, and that actually helps form relationships on the fly, which is really hard to do with relational databases. Cassandra API. This is a column-oriented. This is a column-oriented database, and the advantage of using a column-oriented database is that data in columns is stored in close physical proximity. So it groups the columns in close physical proximity, which means that if you want to run calculations on these columns, you don't have to span across multiple machines to get the data. It's because it's stored in close physical proximity. So it's great for analytical work. So, given all this information and everything Cosmos provides, the next question, I guess, a reasonable person would ask is, which one should I use? So I would like to kind of present the concept of polyglot persistence. So let's say, and I'm kind of giving a thought experiment here. Let's say you wanted to do your own LinkedIn. And if I had to use various Azure services, this is how I would start thinking about it. My profile pages, they have very property-oriented data, and I can kind of group different profiles under a person. So I would use profile pages SQL API for storing profile information. To find out people you may know, like second level, third level connections, I would use the Gremlin API because that's a relational, that's a super relational database which helps you traverse relationships and find those very easily. For the visits logged, which is going to be a large number of visits, I would probably use something like Table API. Now, whether I want to use Table API or whether I want to use Azure Table Storage, that would depend on the type of performance I'm hoping to get out of that. And if I wanted to do something like, summary of years of experience or summary of skill set, I would use a column database like Cassandra API. And finally, there is still room for a traditional RDBMS like SQL Server. For instance, if I wanted to run hardcore asset-based transactions like billing, I would still use SQL Server just for that portion. So as you can see, we are living in a polyglot world, so it's time to start thinking about it that way. CosmosDB provides turnkey global distribution. CosmosDB is a ring 0 service, which means that when Azure stands up a data center, one of the services that are available by default is Cosmos. You can always click and add more regions, and once you add a region, it becomes fully functional and starts fulfilling SLAs within a matter of minutes. Cosmos DB is always on, and if you deploy Cosmos in only one region, you get 4 nines of SLA. And if you deploy it in more than one region, you get 5 nines of SLAs. So Cosmos is a distributed database. As you can see in the picture, you can add or remove regions with a single click of a mouse. Choosing the required region depends on the global reach of your application and the location of where your users are located. Cosmos DB will seamlessly replicate your data to all the regions associated with your Cosmos account. Cosmos DB has something called a multi-homing capability, and this allows your application to be highly available. So what is multi-homing capability? So let's say that you have an application in the East US and West US. So what happens is multi-homing capabilities allows any incoming queries to Cosmos to find the nearest region, applications to find the nearest region without any changes in configuration, code, or connection strings. So in this example, my Cosmos DB, it has two instances, West and East. So the data I see in both the regions will be the same because they'll be replicating. So let's take this example. There is a traffic manager, as you can see to the left of the screen, and then I have my Azure App Service applications deployed in both regions, just to make sure that my customers in the US get to the nearest region for lower latencies. As Cosmos DB gets a request, the traffic manager will route it to the nearest app service region, and from there it will make a Cosmos request, and the Cosmos Multihoming API will determine which region to connect to. So later on when we see how to get the connection strings, you'll see that actually, why don't we do that right now? So I will switch over to a Cosmos instance. So this is a Cosmos instance, and I am switching over to the keys region, and I want to get a connection string. So you can see that in the connection string. So for this particular region, you'll see that, that there is no information on whether it's connecting to east or west, even though this application is in both regions. So, and what enables this is the multi-homing capability of Cosmos. Now, when you distribute Cosmos across regions, you have two options, whether to do have a master region for writing, and then it distributes to other regions from where it can be read, or you can write to multiple master regions. So we'll see how this works. So in this instance, I have one that's deployed to both east and west, and my east is the primary. So actually, that is how I have my current instance here deployed. So it's deployed to the east and west. And in this case, my east is my primary, but I could always switch this out, and it's deployed to the west. And by the way, if you want to add another region, for instance, if I wanted to deploy Cosmos to Asia, I could simply click on this and hit save, and it would become functional in a few minutes. So let's say I have my application east, I have a west as the primary, so any writes will go into west. So even if I get a write request from the east app service, it will still go to west, and then the west replicates over to east. So then you'll see that the reads, because of the multi-homing, they simply read from the nearest region. But let's say the primary gets switched to east. And this could happen for any number of reasons, including suddenly all of my customers came on East Coast. So how do I handle this? I switch my primary to east, or I could have some issues in the west coast. So either of this would kick in that type of scenario. So in that case, my writes would automatically go over to the east coast now, and then it would get replicated to the west, and you can still do reads from the west. In multi-region write, the difference is that your primary, both regions work as primary. So depending on whether you're coming from the east coast or west coast, you write to the nearest region, and then it replicates over time to the other regions. So you have both options. Again, the usage for, obviously, if you enable multi-region write, that is going to be an added cost. So again, which one you choose depends on your use case. So Cosmos is a NoSQL database, and it's so one of the things we have to talk about is consistency, which means that when a database is distributed across the globe, and let's say you write data to one region, the laws of physics dictate that it takes a while to replicate to another region, whether it's single-digit millisecond or whether it's seconds. It's still a while. So that is why we have to talk about consistency. So we have 5 different consistency levels in Cosmos. So as you can see, the list goes on from here. So obviously, strong is something that you'll be familiar with. So strong consistency means when you write the data at a particular time interval and do an immediate read, you read the latest value. So as you can see, as this progresses and it updates values, when you do the reads, it's always reading the latest value. This is very similar to relational databases. The subsequent read will only see the latest write, or if it's not able to get the latest write, it'll fail. It'll show an error message. However, if you deploy a Cosmos DB with a strong consistency, this would be a single region deployment only. So an example for this would be financial transactions. Cosmos offers something called bounded stillness. This means by choosing any level that's not strong, you get multi-region support. In bounded stillness, the reads lag the writes by either an interval, certain fixed interval, or a fixed number of updates. And the thing to note is they're always in order. So let's say in this instance, the reads lag the writes by 2 updates. So the first 2 writes, when you do the read, you don't get any values. But by the third read, you start getting the value of the first read. So it's basically lagging. And the next consistency level is called session, which is a little hard to explain, but it's also the default for Cosmos DB. So when you create a Cosmos collection, session is your default. And what this is if you open a session, if your application has an open session with Cosmos, that particular session actually gets strong consistency, as you can see on the left. But outside of that session,
we do have one question. How
Yeah.
is Azure Table Storage Premium in Cosmos compared in cost to traditional Azure Table Storage?
So I don't have the exact cost, but from having used Azure Table Storage as part of the storage Azure Storage family, that is very cheap storage. So you can store. It's not about terabytes of data. You can store terabytes of data for pretty cheap. So in Cosmos, again, it's not necessarily about the amount of data, like you get charged for the amount of data, but you get, remember I talked about throughput in an earlier slide. So you get charged by the throughput. So if you configure it for higher throughput, you get charged more obviously. So you can actually uh, crank it up as much as you want depending on your use case. The one advantage of using Cosmos for Azure Table Storage is the global replication becomes very easy. So if you ever used Azure Table Storage and you had to putz around with the read access, GRS, and zone redundancy and other things, Cosmos makes global distribution very easy. So hopefully that answers the question. I would recommend looking at the Azure calculator for more details, but definitely understand what you gain by using throughput and global replication when you use Azure Table Storage, when you use the Table API in Cosmos as opposed to Azure Table Storage.
All right, awesome. Thank you.
Thank you. It's a great question. I'll keep them coming. So in this one, you'll see that so on the left side, it's strongly consistent, but on the right side, where it says outside of the session, you can see that it's completely gone wacky. So when I write value 1 and then I try to read it, I don't get anything. When I write value 2, I get it immediately. And when I write value 3, I seem to get value 1. So this indicates that the writes are not in order of read, or the reads are not in order of writes, but also the amount of time that it lags is not certain. So this actually indicates eventual consistency. So when you use session, you get strong consistency within the session and eventual consistency outside of the session. Consistent prefix, we're almost done with the consistency models. I want to finish up with consistency prefix. This actually, this again shows that the reads are lagging writes, but there's no predetermined amount of time or number of operations that it lags by, but you can be assured that your reads will always be in order of writes. So you will not get the value 3 before value 1 or 2 in this example. Finally, eventual consistency. This is one where reads and writes could be completely out of order and could lag by an indeterminate amount of time. There is no order guarantee, and the understanding is that the data will eventually converge. So if all the writes stop happening, ultimately the system will be consistent. A great example of this is social media posts. So I could, for instance, I could put up a post on some type of social media and it takes a while to update. And some people see it, some people don't see it. So that's a great example of eventual consistency. Partitioning is really important in Cosmos DB. You have two types of partitioning, logical and physical. Logical partitioning is selected by the user, and physical partitioning is abstracted away from the user. One physical partition may contain one or more logical partition, and the queries perform better when they're using the partition key. This is the most important aspect of designing a Cosmos DB instance. So please make sure that when you start using Cosmos DB, particularly the SQL API, you read up data modeling for document databases. So what that involves is, let's say you have a relational database and you have a parent table and a child table. Instead of forming relationships, what we do is we usually either embed the data within the table, or we kind of use a key-based approach, but there's no direct relationship. It would have to be done by the application outside of the database. Again, that's a whole topic on itself. So definitely read up data modeling for NoSQL databases. So indexing, when your data comes into Cosmos DB, it's automatically indexed, and this is what makes it helps it schema agnostic, helps it become schema agnostic. So let's say I have a record that comes in that has location and exports. You'll see that it's indexed by the column. So it indexes the location in the exports column, and that way if I search for records with location 0, it will return those based on the index from, as you can see from this table. Now I could also have a record that comes in with location and headquarters, and it would index those two. Now, the advantage of and the schema agnosticism comes into play because you could have one record that has location and headquarters, and the second one has location and exports. And if you search based on location, you'd get both records. But if you only searched on exports, you'd only get one of the type of records. So some of the things to keep in mind with indexing is in Cosmos, you can, unlike Azure SQL, where you get you get measurement in DTUs. In Cosmos, the RUs or the request units are actually returned by the query, and I'll give you an example. So when I actually execute a query in here, it will return some data. So let's do this. I'll run through this and I'll get started on query. Time to live. So one of the things I want to talk about Cosmos is change feed processor. Change feed processor is basically it's a production quality RSS feed for incoming data and updates to data in Cosmos. So what you can do with the change feed is that you can have multiple services consume your change feed, and they look at the same change feed, and based on various aspects, you could run different operations. So for instance, if you have a record that comes in that has order information on an e-commerce website, you could send that to the change feed, and from the same change feed, you'd have a microservice, one that handles the inventory, one that handles shipping, one that handles tax, and so on. Security, so if you look at the Cosmos instance, you get various, can set, handle security at various levels. So, for instance, you could add a Cosmos instance to a virtual network, and you can restrict the IP addresses that connect to it from the outside or from the inside. You could allow even from Azure data centers, you can restrict the connections or not. So you can set security at various levels, cross-origin requests. So if you do any kind of coding with JavaScript or anything, you must be familiar with this. So you can set cross-origin resource sharing over here. And the main thing I want to talk about was the keys. So when you create a Cosmos instance, you get read-write keys and read-only keys. And these provide connection strings, but they also provide URI and keys, and you can use this in connection strings to connect to Cosmos DB. Now, if it ever gets exposed, you can regenerate a key. So one of the practices that you could do with Cosmos is, obviously, when you create a Cosmos instance, you want to do it with with ARM templates, and then it takes the connection information and puts that inside a key vault, and your application should actually be connecting to the key vault to get this type of information. Cosmos also encrypts data in rest, at rest, and in motion. So and Microsoft takes care of all these securities. Cosmos instance, so uh, Cosmos, the account is basically where you get uh, the keys, the URI and the keys. A database is basically a logical instance that helps manage various data stores, and the data stores are known as containers. Now, these have nothing to do with Docker containers. These are a container for data. And based on what type of Cosmos API you use, if you use a SQL API, it's a collection. If you use table API, it's table. If you use Gremlin, it's graph, so on. So, so each container can have, it contains items, which is basically the data. Again, if you use SQL API, it's document data. If you use Graph API, it's nodes and edges. If you use a table API, it's rows and so on. So that's the item. And then you also have stored procedures, triggers, and user-defined functions, and all of these additional items. Now, as you can see, they brought in some of the concepts of SQL Server into Cosmos. So it's if you worked with SQL Server, you'll find it an easy jump to Cosmos. But I wanted to caution you that some of these things like stored procedures and triggers, these are not like a SQL Server scripts. These are actually JavaScript code that gets uploaded to the Cosmos server, and then it runs server side. So a great example of using a stored procedure, for instance, would be to handle would be, if you wanted to handle atomic transactions within a container, you could do that with stored procedures. Triggers, user-defined functions. Let's say you have a cost and you wanted to calculate tax on the fly, you could use a user-defined function to do that. So I'll quickly jump. Do we have any questions? So. All right, I guess I'll go ahead and jump into code. So I wanted to talk about a couple of types of code. So let's see. So to create a Cosmos account, first, obviously, we would need a resource group in Azure. And from there, I can go in and search for Azure Cosmos and create. And then you create that under the same group. You provide account name. And this is where you have to be careful. Let's say you want to create a Gremlin API, then you pick that at creation time. Now, Cosmos stores all the data as JSON in the background, even though it's Gremlin. But where we want to select these is because of the type of, like if you want to connect, let's say you want to store data in Mongo. So if you select the right API, then it actually provides support for the Mongo via protocol. The other area this is useful in is it actually, you get a user experience based on the type of API you selected. So if you select the wrong API, you may not get the proper user experience that you're hoping for in the portal. Cosmos supports Jupyter notebooks, and you can enable that. And this is the part where you enable geo-redundancy and multi-region rights. So you have to enable that at a higher level. So once you create this, you get something. So you get something like this. So this is this is a Cosmos DB account I created for storing SQL API data. So from there, what I want to do is, let's see. So I have this thing called a data explorer, and for this is where I can go in and handle, query the data, look at my data, and so on. So in here, I'm going to create a container. and this contain I call it a container because it will store SQL API JSON documents. So I'll call this Kickstarter data because I have some Kickstarter sample data I downloaded that I want to import into Cosmos DB. So I'll call it Kickstarter data. And let's go and look at the Kickstarter data that I have. So this is some sample Kickstarter data I downloaded. So it kind of looks like this. It's a CSV file. I'm going to import this into Cosmos. And so the number one thing I want to do is whenever I create a Cosmos account, obviously I want to know um, what type of partition key to use. So I'm looking at this data and I'm not sure what to use as a partition key. I don't want to use ID because it repeats for every single record. I don't want to use the name because again, there's not going to be a proper distribution of names. I could use the category. So that is a potential uh, partition key because there'll be an even distribution of data across categories, or at least somewhat even distribution. Um, I don't want to use the currency because there are only two types of currencies, and it's possible that one may be way more popular than the others, so I don't want to use that. Again, I could use the goal possibly, but I'm not sure. I prefer to use more. Again, the goal could there could be a large variation of goals, so probably not. I don't want to use states, so I'll stick with currency. So what I'm going to do is I'll go back to my uh, portal and I'll say I want to use category as the partition key, and I'll create this. When I'm creating this, it takes a minute to create, and I go in here. There you go. I have a Cosmos instance. I look at the settings. It says, okay, so you have some of these things. It automatically sets the indexing policies. So again, that's stuff that you don't have to worry about. I look at the scale and it says 400 throughput. All right, so I'm all set on here. I'm going to start importing my data. What I'll do is I use this tool called the Azure CosmosDB data migration tool. My source is a CSV file. My target is the um, Cosmos connection string that I got from here. So take sample Kickstarter data. That sounds right. Okay, so I want to use, let's see, what is it called? Sample DB. So sample DB. So I'll hit verify successfully connected. Great. So my partition key is category, and my ID field is called ID. And collection throughput is, it'll ignore this if you already have a collection throughput set. It's going to ignore this. So next thing I'll do is I'll go in and run this, and it'll start importing it. One thing I want to do is watch out for any kind of errors or anything like that, which tend to, oh, look, there is an error. So it says request rate is large. So I'm going to cancel this. Usually when you get a request rate as large, you may also see this when you use 429. It's a 429 HTTP status message if you're using the SDK. This means that you have not provisioned enough throughput. So I'm going to increase this to 4,000, and I'll save this, which means now I have more throughput, and I'm going to start importing this. So I'll do a new import, use the same settings, and start the import. As it starts, transfer data, and I don't seem to have any issue. Sure. Yeah. Okay, so stored procedures into source code. So a stored procedure is basically JavaScript code. So you could attach it to your project, and that way it goes into source control. So uh, it's a very generic code. It's like a function call in a JavaScript code. So what you do is you write your stored procedure, and then once you create a collection, you simply register that stored procedure to a collection, and it will automatically upload that. But it can stay as part of your code, and you can check it into your source control.
Thank you. And I think there was an audio issue when I asked the question. So the question that you answered to was you were giving us recommendations on how to put store procedures into source control. Sorry about that. And then the second
Yeah.
one is any recommended articles on choosing a partition key?
Any recommended articles on choosing a
Or just
partition key?
resources that you may know what people should look at?
Yeah, so if you Cosmos, they do a really good job of documenting. Like Microsoft Docs, it's a really awesome site. So I would generally read up on data modeling practices and the partitioning practices for on the Microsoft site itself. And the reason I suggest that is because Cosmos DB is a very particular product that is only provided by Microsoft. So they have certain uh, tips that they provide that are really helpful. So definitely look at the Cosmos DB documentation on Microsoft's site. Again, the general idea is very easy. You want your data equally distributed, and that's number one. So your partition key will distribute your data. Generally, it will distribute it equally. And the other thing is as far as possible, you want to use your partition key in queries. So that's the recommendation. Select the
All
partition
right,
key.
awesome. Yeah, back to your
So
demo then. Thank you.
yeah. So what's happening is after I bumped up the throughput, it seems to be importing. I'll stop this at this point. See if it's importing any records. You'll see that it already started importing certain records. I can click on these records, and you'll see that it's they have different values in them. So the next thing I will do on here is I can actually go in here. So right now it's selecting all the records. As you can see, select star from C. So you can actually see that you're starting to write SQL style queries in here. So I want to use something like, instead of doing select star from C, I'll make it more useful, and I will do something like select star from C, where my category, which is my partition key, equal to poetry, and then I'll run a command, and you'll see that it's actually returning some records. Now, one thing I wanted to do was oh yeah, so okay, so I tried to I kind of glossed over that slide earlier, but we were there was a slide that was talking about time to live or time to live, however you want to pronounce it, and that is basically the amount of time um, document has to live on the server. So right now you see that this contains probably thousands of documents. So what I could do is, let's say I wanted to start aging out records. And the way I defined the aging record is a record uh, that got inserted and updated, and the amount of time that passed after the last update would be the age of the record. So let's say I want to age out a record, and there can be a number of reasons for doing this. Let's say I have a sale for a particular item on my e-commerce store, and I want to age it out after a day. I could do that. So this is how I would do it. So instead of I would use this property called time to live, and this is actually in seconds. So what happens is, after the passage of this amount of time from the last update, the record will automatically be tagged for deletion and disappear from your collection. So for instance, let's say I want to uh, uh, delete all the records in this collection. I'll set it to 1 second, save, And then when I come back in here and hit refresh, my records have disappeared. So that's an easy way to delete your records in Cosmos. Don't tell anyone I told you that. And again, you can run SQL style queries. Let's see, isn't that a query? New SQL query. So I could also open up a new SQL query, and I can run queries like select. Let's say I want to count all the documents in here. I'll do select value count 1. Right now I've deleted all of them. Oh, it's still coming back. It's probably pulling. It's a soft delete, so it stays for a while, but you would probably not see it returned in queries. So you'd not see it returned in queries, and the query stats actually gives you what each query costs. So remember the request units, you could get that from the query stats. So these are some awesome ways of using Cosmos. If you wanted to do the consistency, this is where you set the consistency in the portal. Although when you do start doing operations at the resource level, I would Azure ARM template, or at least writing code to do that as opposed to using the portal. So you could add an Azure function, and the Azure function could actually look at the Cosmos DB change feed and do operations based off of that. If you wanted to scale your Cosmos DB collections to up and down, you could use the scale and settings. You can also use monitoring alerts metrics, which are pretty standard Azure resources. You could set them from the portal, or again, probably use ARM templates. I'll repeat that uh, any number of times. I wanted to jump into some code. How am I doing on time, guys? I know that I'm pretty close. Should I keep going?
Actually, right at time. So not a lot of time.
Okay.
So. Yeah.
Some minutes.
So
Just okay. So I wanted to show this code real quick. So this is something that I use to insert simple. This is actually a great section of code. So I have an endpoint and a primary key which I get from the portal. I actually, if you go look at my project, I've added this Microsoft.Azure.Cosmos NuGet package, and I have this in the console application. I can call this thing called Cosmos client using that endpoint and the key, and that actually instantiates a connection with the Cosmos instance. And what I can do with this is, if the database doesn't exist, I can create it, or I can use the existing one. Similarly, if a collection doesn't exist, I can create a collection with using code. So this is actually pretty powerful. You're actually creating everything directly from code. And then I can instantiate a bunch of objects, and I insert them into the insert them into the insert them into the collection. So this is a pretty powerful section of code, and you'll see that when I go to .NET Run, it actually goes in and it'll connect, and it will instantiate a collection, instantiate a database, instantiate a collection, and start inserting records. And because I have the demo gremlins, but speaking of which, I also have some gremlin code that will do something similar. Again, just a couple quick minutes. So I'm using some connecting to the gremlin instance that I created using a key, and I have a database and a collection, and what it's doing is it's going in and it's creating a person record and with some properties. It's creating 3 people records, and then it's starting to add relationships. So I can say that this person works with this person. This person actually is a member of this establishment, and this person is also a member of the same establishment. So when that query runs, you'll see that it ran. And when I go back to the portal, I'll switch over to the Gremlin collection, and almost done. Just wanted to. When I execute the Gremlin query, it'll start showing, the actual data inside the window. So you can see that, this is a person record and this is an establishment record, and it starts showing the relationship between them. So for instance, this establishment has two people as part of it, as we showed in the code, and so on. So it's a really powerful way of doing things. You're basically writing code to not only and handle your data, but you can actually handle the resources themselves with code. Infinitely scalable. Microsoft is completely maintaining everything, keeping it up. They keep maintaining your security and everything else, and all you have to do is focus on solving business problems. So this is why I'm excited about Cosmos DB. And thank you for that. So I will try to put this in a GitHub application and add this to the YouTube video comments or something. That way people can have access to these code samples.
Oh, just super useful. I've been doing bits here and there with Cosmos, but I've never sort of connected all the dots, I guess. So yeah, thanks a lot, Santosh. This is really cool.
Thank you. I appreciate it.